It was September 15th, 1977. The Voyager 1 spacecraft had just launched from Cape Canaveral, beginning humanity's most ambitious journey to the outer planets. But hidden in its cargo bay was something extraordinary: the Golden Record, a 12-inch gold-plated copper disc containing sounds and images from Earth. Carl Sagan called it a message in a bottle cast into the cosmic ocean. The record held greetings in 55 languages, music from Bach to Chuck Berry, and the sound of a human heartbeat. It was our attempt to say hello to whoever might find it among the stars. 47 years later, Voyager 1 crossed into interstellar space, carrying that message 15 billion miles from home. And now, the universe has sent us a reply of sorts: PSR J0952607, a pulsar spinning 707 times per second, discovered in data that had been sitting unnoticed for over a decade. In March 2017, the Fermi Gamma-ray Space Telescope detected something unusual: rapid pulses of gamma radiation coming from a seemingly empty patch of sky in the constellation Sextans. The signal was faint, buried in background noise, but it repeated with clockwork precision every 1.41 milliseconds. That's faster than a hummingbird's wing beat, faster than any pulsar ever discovered. For years, the data sat in archives, waiting. Then came the breakthrough. In 2024, citizen scientists working with the Einstein at Home project, volunteers who donate their computers' idle time to search for cosmic signals, found the pattern hidden in the noise. What they discovered defied expectations. PSR J0952607 isn't just fast. It's fast. It's impossibly dense, packing more mass than our Sun into a sphere just 12 miles across. A teaspoon of its material would weigh as much as Mount Everest. And it's spinning so rapidly that its equator moves at nearly 25% the speed of light. But here's where it gets strange. The pulsar sits in a binary system, locked in a deadly dance with a white dwarf companion. Every 6.4 hours, they orbit each other, so close that the pulsar is literally consuming its partner, stripping away material in a process astronomers call recycling. The Arecibo Observatory, before its collapse in 2020, had been tracking similar systems for decades. But this one was different. Follow-up observations with the Green Bank telescope revealed something unprecedented. The pulsar's magnetic field is weakening in real time, dropping by 0.1% per year. At this rate, it will become magnetically invisible within a few thousand years. Then came January 2024. The James Webb Space Telescope turned its infrared eye toward the system and found something no one expected: a debris disk. Surrounding the binary pair was a ring of material, dust, gas, and possibly larger fragments, stretching nearly 2 billion miles into space. Spectroscopic analysis revealed the disk's composition: carbon, silicon, iron, and traces of heavier elements. But most intriguingly, Webb detected organic compounds, complex carbon molecules that shouldn't exist in such a hostile environment. The radiation from the pulsar should have destroyed them instantly. The European Southern Observatory's Very Large Telescope added another puzzle. Using interferometry, astronomers mapped the disk's structure and found it wasn't random. The material was organized into distinct rings, almost like the grooves on a record. Each ring showed different chemical signatures, as if they were formed at different times or from different sources. Is this natural? Almost certainly. Pulsars are known to create complex magnetic fields that can organize surrounding material. But the precision of these rings, their chemical diversity, and the presence of organic molecules in such a radiation-bathed environment raises questions. Harvard's Avi Loeb, never one to shy away from bold hypotheses, has suggested we can't rule out artificial origins entirely. When nature creates something this organized, this chemically complex, in such an extreme environment, he notes, we should at least consider whether we're seeing the remnants of technology designed to survive near a pulsar. Meanwhile, radio astronomers have detected something else. The pulsar's signal isn't perfectly regular. Embedded in its clockwork rhythm are tiny variations, microsecond delays, and advances that seem to follow a pattern. Some researchers suggest these could be gravitational wave signatures from the binary system's orbital decay. Others wonder if they might be something more. The timing is remarkable. Just as Voyager 1's golden record reaches the edge of our solar system, we discover a pulsar system that seems to be broadcasting its own complex signal, a cosmic lighthouse spinning 707 times per second, surrounded by organized rings of material, some containing the building blocks of life. Astronomers have mapped several key observation windows as this system evolves. December 2024, the extremely large telescope comes online, offering unprecedented resolution to study the debris rings. March 2025, a rare alignment will allow gravitational wave detectors to measure the system's orbital decay with extreme precision. August 2025, the pulsar will pass behind a distant star, creating a natural eclipse that will reveal details about its magnetosphere. 2026-2027, as the white dwarf companion continues to lose mass, the pulsar's spin rate may change dramatically, possibly revealing new physics. What makes this discovery even more intriguing is its location. PSR J0952607 sits in the constellation Sextans along the galactic plane, where our view toward the galaxy's center is richest in stars. It's the same general region where SETI researchers focus their searches, believing that any galactic civilization would likely emerge from the dense stellar neighborhoods near the core. To most scientists, this is simply an extreme example of stellar evolution, a natural laboratory where matter behaves in ways we're only beginning to understand. The organized rings, the organic molecules, the precise timing variations all likely have conventional explanations rooted in the exotic physics of neutron stars. But as we stand on the threshold of becoming an interstellar species ourselves, with Voyager carrying our message to the stars and new telescopes revealing the universe's hidden complexity, discoveries like PSR J0952607 remind us how much we still don't know. In less than 50 years, we've gone from sending our first message to the cosmos to discovering pulsars that broadcast signals across thousands of light years. Each discovery reveals new layers of cosmic complexity, new questions about what's possible in this vast universe we're only beginning to explore. What do you think? Could organized matter around pulsars be nature's way of preserving information across cosmic time? Drop your thoughts in the comments. I'd love to hear them.